So on the top of page 346, this is going to be our example. We're going to graph y equals -5 times 3. I will already write it factored out. If it was 2x plus 8 up there without brackets, you would have to factor it out to look like this. Because again, whenever you have a horizontal stretch or compression or reflection with the horizontal translation, you always have to factor it out. And we'll put a -7 at the bottom. So whenever you're graphing exponential functions, the first thing you have to determine is what is the parent function that went with this. Something to the x. What is the base graph of this one? It's going to be the 3. So here is the base of the 3, and there's the exponent x. And I put boxes around those because sometimes you're going to be tempted to include those in your transformations. But those are part of your original graph. Also, sometimes you're going to be tempted with a -5 out in front to multiply -5 times 3. Doesn't it look tempting just to write that as -15? But order of operations say we have to do exponents before we multiply, so you wouldn't be allowed to put that -5 and that 3 together to make -15. So when we're graphing this green graph, we're going to start by saying, well, I know what 3 to the x looks like. There's an asymptote here at y equals 0. The 2 points that I know quickly to graph are 0, 1, and 1, 3. And now I can take those points and do transformations with those. So we're going to look what happens to 0, 1, what happens to 1, 3, and what's going to happen to our asymptote y equals 0. And again, when we did our transformations unit, we went from left to right. So going from left to right always deals with our stretches and compressions first. What's the -5 going to do? It's going to affect your y by multiplying it by -5. And the next number is not the 3, but the 2. What's that 2 going to do? It's going to multiply your x by 1/2. You can do both of those at the same time, because one is affecting the y, one is affecting the x. Well, if I multiply y by -5, I'm going to get -5 here and -15 there. And x by 1/2, this will still be 0, and this one will now be 1/2. The next things that when I go from left to right, I hit the 4 and then the 7. The 4 is going to make it go which direction? Left 4. And the 7, down 7. So now if I go left 4, I'm going to go -4, and down 7, -12. Left 4 will give us -3.5, and down 7, -22. And finally, we haven't done anything with the asymptote. The only thing that's going to affect the asymptote, multiplying anything by 0, the y value by 0, won't affect it. The only thing that's going to affect that asymptote is when you move it down 7. So what's our new asymptote going to be? -7. So now we have enough information at -7, we can draw our asymptote. And then we can plug our 2 points. We're going to have -4, -12. 1, 2, 3, 4. -4, -12. Just estimate it there. And -3.5, -22. So those are the 2 points that we have. How is this enough to show? Well, first of all, it's going to have to go between these 2 points. From here, you're going to know it's going to have to go this way. The shape of an exponential will always be the same. It's going to always approach that asymptote. Now, if we think about the transformations that have happened, the first thing was that -5. Well, the 5 is going to stretch it, but can you see that that negative, if your y values become negative, it's going to get flipped down. Looking at our original function, can you see if I took this original function right here and flipped it down, now it has this shape, which matches the shape of our graph. And then we moved it left and right, left and then down, so it makes sense that it would look like this in the end. So when you're graphing your exponential, all you need to do with your transformation is take those 2 original points, do your transformations and plot them. You'll need to draw your new asymptote after it's been moved up or down. And then your shape of your graph has to have the same kind of shape as the original one. So we can't all of a sudden draw it with straight lines or try to loop it back to that would not be a good looking exponential graph.